Good morning. We are going to move on to 8.4 today and talk about vertex form. So the vertex form of a quadratic is the equation a times x minus h quantity squared plus k, which is this formula right here. And what's nice about vertex form is we don't have to do anything to be able to find our vertex. So A, H, and K all represent something. The H is either your left movement or your right movement. Now what's important is it's actually opposite of what you think. If we move left, we think that that's negative. But in actuality, left means that H is positive, and right means that H is negative. So you have to make sure that you're careful when you're looking at your vertex. Now the K is the movement of up or down. And K, unlike H, is exactly what you see. So if you see a positive K, positive means we are moving up. If we see a negative K, then negative means we are moving down. And what's nice about our H and K values is we can plug those in and identify as an ordered pair your H comma K, and that ordered pair is your vertex. And then your axis of symmetry, if you recall from earlier, our axis of symmetry is our x value of our vertex. So our x value of the vertex is the H, which means our axis of symmetry is x equals H, whatever H is. And then your A value, which we will talk about in the next coming days, but our A is telling us if the graph is opening up or down, and it also tells us if it's stretching or compressing. And then this note here is just kind of reiterating what I was telling you about your H. It's always opposite of what you actually see and what you think. So let's look at some problems. Okay, so it says to find the vertex and the axis of symmetry. So remember our vertex is the ordered pair HK. So in order for us to identify the vertex, we must identify what H and K are. Well, here is our H, and here is our K. So what I see with the H is a -2, but in reality, H is opposite of what I see, which means H is 2, and K is 5, which tells me that my vertex here is 2, 5. So it's the ordered pair 2, 5. And then our axis of symmetry, which I'm going to label as our AOS, remember is the equation for the x of the vertex. So that means x equals 2 in this problem. And there is our vertex and our axis of symmetry. Let's look at this next one. So we have f of x equals 1/2 times x minus 4 quantity squared, and that's it. So we have to remember that our vertex is HK. So our H is on the inside, which means this is H. And K must be over here somewhere. Well, since there's nothing there, that means that that's really like plus 0. And if you have to write that in, then do so that you don't forget about your K. So again, our H is opposite of what we see. We see a -4, which means H is 4. And then our K is 0. So that means my vertex, I'm just going to put a V, is the ordered pair 4, 0. And my axis of symmetry is the equation x equals 4. And there would be our vertex and our axis of symmetry for that problem. Okay, let's try another one. So again, it's asking us to find the vertex and the axis of symmetry. Here is H and here is K. So H is opposite of what I see. I see a positive 3, so H is -3. And K is a -7, which means my vertex is -3, -7, and my axis of symmetry is the equation x equals -3. So remember that this H is telling us that we are moving in the left and right direction, and K tells us up and down. So if we were to use words here, this H is telling me that I'm going left 3, and the k tells me that I'm going down 7. So those are just the words there.